Good afternoon, students. Ms. Codner here, welcoming for you to the first day of April. This lesson is a combination of what happened on March the 31st, which was the last day of the third quarter, and also for parts of April 1st and also for April the 4th. So we really have 3 days. The reason why we had an early dismissal on the 31st, so in order to have everybody go through this lesson, I'm just basically going to teach the whole thing on one of the videos. So first off, we need a pencil, calculator, and some loose leaf paper for an activity. So what I did for the last grade for third quarter is I had an activity that was placed all around the room. It was an activity that I wanted to do once before, but I figured that let the students do this one time. They can get into groups of 2 up to 3, and they worked out the problems, wrote it on a separate sheet of paper, and they handed that in, and that was their last grade for the third quarter in conjunction with the quiz that they took on the previous day. So I gave them like 54 minutes on the 31st. That's how long the class period was. So just to be fair for today's class, which is April 1st, gave them the 54 minutes to complete the activity, and then they turned it in, and it was a total of 12 problems. And then once they turned all that in, we went right into factors and greatest common factors. So this part of the lesson, my A-Day class, which will be on April the 4th, this is what they're going to see. Okay, so everybody's going to be on the even kilter from this point on. So we're going to deal with factors and GCF, which stands for greatest common factor. So when 2 or more numbers are multiplied, those numbers are called the factors. So for example, for number 90, I can say 1 times 90. That means 1 and 90 are factors of 90, because when I multiply them, it will give me my solution of 90. Also, I can say 2 and 45. I can also say 3 and 30. Okay, I can also say 9 times 10. So these are just some examples of factors for 90. So if I wanted to go in order, I could say factors of 90 would be 1, 2, 3, 9, 10, 30, 45, 19. I know there's definitely like 5 times 18 can go in there as well. So those are just examples of factors of 90. And then we can do the same thing for 36. So we can say 1 times 36 is factors. I can say, what, 3 times 12. I can also say 4 times 9. Okay, a lot of other ones. So that's basically give me an idea of what factors are. So number 1 and number 36 are factors of 36. And I can also use negative numbers. So if I wanted to, I could have said a negative 1 times a negative 90. Those are also factors of 90. Okay? So once we dealt with the factors, then we talked a little bit about prime numbers and composite numbers. So what's a prime number? So a prime number is a whole number greater than 1 whose only factors are 1 and itself. So whole numbers greater than 1. If I want to list all my prime numbers, the first prime number I will write down is not going to be 1. 1 is not prime, because anything times 1 is going to be itself. But that 1 is not going to be the starting of just the prime numbers. So the first prime number is actually going to be the number 2. So you'll actually see that written as a question on SATs, and a lot of students usually miss that because everyone thinks that the number 1 is your first prime number, and in actuality is actually 2. So another prime number will be 3. Another one will be 5. You can say 7. You can say not 9. I always do that because you get so used to the pattern. It's not going to be 9 because 3 times 3 and 1 times 9 would equal 9. Okay? 11 will be 1. 13 will be 1. 17, also 19, and there's some others. Okay? So a prime number is a whole number greater than 1. So in this case, when I'm talking about prime numbers, I cannot include the negatives. Okay? So I cannot say -2 because -2a is not greater than 1. Okay? I cannot say 1/4 because 1/4 is not a whole number. So the next number is called the composite number. So what a composite number is a whole number greater than 1 who has more than 2 factors. So what I mean by that, let's say a composite number could be, example would be 4. In order for me to say 4 is a composite number, I have to think of like 2 or more factors. Meaning, I can say 2 times 2 will give me 4, and I also can say 1 times 4 will give me 4, which this will give me a total of 1, 2, 3 factors. Okay? So I'm looking at the numbers that I'm using. The numbers I'm actually using are my factors. Another example will be, let's say 8. The only way I can get 8 is 4 times 2. And I also can get 8 at 1 times 8. So the number of factors I have in this case, I have the number 1, I have the number 2, I have the number 4, and the number 8. So I have 4 factors that's dealing with 8. Let me do one more. Let's say 10. So in order for me to get the number 10, I can multiply 1 times 10. I can multiply 2 times 5. Okay? So now I got 1, 2, the number 5, and the number 10 are represented as factors. Notice it's definitely more than 2 factors. Okay? So basically a number that you can multiply 2 other numbers other than 1 in itself and to get your answer for that number. So we have the composite numbers, which is a whole number greater than 1 whose only factors are 1 in itself. And then you have composite numbers, whole numbers greater than 1 who has more than 2 factors. So now let's see if you guys understood that. So looking at it, we're going to find the factors for each number, then classify each as either prime or composite. So let's look at number 1. We have a number 52, and I know I can say 1 times 52 will give me 52. But what else? Is there any other numbers multiplied together to give me 52? I can say 2 times 26, right? And I can also say 4 times 13. So I have more than 2 factors here that can multiply together to give me that 52. So in this case, we have what's called a composite number right here. Now let's look at 20. So for 20, we know we can do 1 and 20. We can also do 2 and 10. And we also can do 5 and 4. So we have more than 2 factors here. So then again, this is a composite. How about number 3, 31? Looks like 31 will be what's called a prime number because the only factors I can think of for 31 is 1 and itself. Okay? So there's no other 2 numbers multiplied together that can give me 31. You can try it, but it'll give you decimals. So it has to be whole numbers, no decimals. For the next one, we have 112. So 112, I know I got 1 times 112. That will give me 112. What else will give me 112? Hopefully you said 2 and 56. So 2 times 56 will give me 112. Anything in the 4 columns? How about 4 and 28, if I'm not mistaken? Okay, so we definitely have more than 2 factors. So in this case, this is also a composite. And how about 72? Now, looking at it, it's a whole number. And I could say, negative 1 times 72, that'll give me 72. Okay, is there anything else that will give me 72? Hopefully you said, what, 2 and 36? So I can say a positive 2 and a negative 36. How about in the 8 times table? How about 8 and 9? But one of them has to be negative, so we can say negative 8 and positive 9, or vice versa. So we do have factors for a negative 72, but is it, so it won't be prime because we definitely have factors, but is it composite? Hopefully you say it's not composite. It will be neither. And the reason why I'm saying it's neither, because it's a negative. Last time I checked, negative numbers is definitely less than 1. So it did state for us to find factors for each of the numbers, which we did. But for me to classify this negative 72 as either prime or composite, I would not be able to do that because it's less than 1. Okay? So just to clarify that, you can find factors for a number, but in order for you to claim it or to classify it as prime or composite, you have to have a whole number and it has to be greater than 1. Okay? So for the first, we worked on this quite briefly, just wanted to touch on it. And then on the fourth, we're actually going to do some additional examples. Okay? So for the last part, I want to talk about prime factorization. And you've seen this before. And the reason why I said you've seen this before, remember way back in either elementary school, you had something called the factor tree? You're probably like, not really, but here we are. So the factor tree, I'm going to think of 2 numbers that multiplied together will give me 12. So you can pick 3 and 4, you can pick 6 and 2, you can pick 1 and 12, but the whole thing about this is I want to be able to factor this 12 out so where the final answer is going to be nothing but prime numbers. So let's say I want to use 3 and 4. So 3 is a prime number. I can't factor that out anymore. But this 4, I can. What 2 numbers multiplied together will give me 4? Hopefully you said 2 times 2. Then I'm looking at the 2's. 2's are a prime number. Notice I circled all the prime numbers. So now all I have to do is just put this in numerical order. So this is basically telling me 2 times 2 times 3 is the prime factorization of my original answer of 12. Okay, if you're not sure, it's 2 times 2 is 4, and 4 times 3 is 12. So all we're trying to do when I talk about prime factorization is I want to break down my original number into all prime numbers multiplied together. So let me try to clarify a little bit with number 90. So for 90, I want to think of 2 numbers multiplied together to give me 90. So I can start out with 3 and 30. I can start out with 10 and 90. Actually, I'll start off with 10 and 90. Or 10 and 9, sorry. So if I start out with 10 and 9, I know that this number 10 can be broken down again to 2 and 5, right? Okay. 2 is a prime number, and 5 is a prime number. So now I'm going over to the 9. That 9 can be broken down as well. 2, 3 times 3, right? Last time I checked, these 3's are also prime numbers. So from here, I knows I got all prime numbers. I don't have to branch out anymore. So all I have to do is just say 2 times 3 times 3 times 5 is going to be my prime factorization of my original number 90. Okay? So that's all you're doing. We're just kind of refreshing our memory with the factor trick. Trust me, there's a method to my madness. Because once we figure this out, we're going to start doing factoring. And if you haven't noticed, we're really going to hit hard on that multiplication scale. So multiplication is going to be key when it comes to factoring. Okay? So we just basically did those. We did that for April 1st. We're going to do this and more on April 4th. But I really want to record that when we get closer to the 4th and the 5th. Okay? So again, we did an activity, collected that activity and put it under the grade for third quarter. So that was my last and final grades. Then we touched upon factoring or factors. And we're going to work on the rest of factors and the greatest common factor, which is GCF. Next class, which will be the April the 4th and the 5th. Now, trust me, we don't have that much time because fourth quarter is going to fly by. We have basically 10 days before a spring moment, as I like to call it. And then when we come back, we have basically like 2 weeks, and then boom, it's HSA. Then seniors have 2 classes before they have to finish up with their last days at Arundel. So we're looking at 15 classes for seniors. And roughly, I want to say a good 18 to 19 classes with the underclassmen. It's going to be that quick. So what I would like to do is factoring and get some quadratics, and then we'll work on our final examinations. Okay? So if there's any questions, any comments, Monday through Friday, first lunch, Wildcat Hour, or just review some of the lessons that are approached on this website. All right, talk to you later.